Hey, Chemsters, this is Mrs. Vandal. I bring you the Chapter 7 Alcohol Reactions Worksheet answers. Now that's a mouthful. So they asked you to show the structures of the possible acid catalyzed dehydration products of the following. That's another long way of saying show the elimination. Okay, we talked about that in our notes. If more than one alkene is possible, then predict which one will be formed in the largest amount. Okay. So let's start off with cyclopentanol. Okay, so here we go. We're going to acid catalyze that. And again, the OH is going to fall off. I could have a beta here or a beta here, and it truly doesn't make any difference. And I'm only going to get one out of that. Okay, so that's my product. About 2-butanol. This brings up an interesting point. So with 2-butanol, you have two beta hydrogens, the hydrogens off of those carbons there. So if I look at the first one, I would get this. If I were to look at the second one, I would get this. And don't forget, you also have water. So the question is, which one is going to be formed in the largest amount? Let's go back and look at your notes real quick. This is the second page of the elimination of the alcohol section of your notes. I think it's 7.8, I think. And we're right here. So it says example, 2-methyl-2-butanol can give two different alkenes. Well, which one is going to predominate? The alkene with the most substituted double bond usually predominates. This means, here we go, that the alkene with the greatest number of alkyl groups, of carbon groups on the double bonded carbon. So here, if I look at this, I have no groups and I have two groups. So that's one choice. Over here, this has two groups and this has one group. So which one predominated? This one, 2 + 1 = 3. That predominates. So let's go back and look at your worksheet now again. All right, so here I have no groups. Here I have one group. Here I have one group. Here I have another group. So I have 0 + 1 = 1. 1 + 1 = 2. So which one predominates? This one does. All right. What about the next one, 1-methyl-cyclopentanol? So here I have the structure. And notice again, I have two beta carbons with beta hydrogens. I have one that's in the ring and one that is part of that 1-methyl group. So if I am going to look at the first one that's in the ring, all right, I would have this, all right. Or if I use the one that is off the 1-methyl, I would have this. So, and don't forget, you also have plus water. So which one predominates? So once again, let's count. How many carbons are on this one? 1, 2. How many are on this one? 1. That adds up to 3. All right, how many carbons are here off of this? None. How many off of this one? 1, 2. So which is bigger, 3 or 2? 3 is bigger, so this one will predominate. What about 2-phenyl ethanol? Well, what's going to happen here? Well, so here is my ethanol is on the first carbon. Here my phenyl group is on the second carbon. So I only have one beta set, if you will. And there I go. Hey, isn't that styrene? I think it is. All right. And then we make our water. That's the only product, so I don't have to figure out which one predominates. Okay. So now we have treatment of 3-butene-2-ol. With concentrated HCl. Again, I took that as I'm going to protonate it, all right? It gives a mixture of two products. Write the reactions showing both products, which will be made in greater quantities. Now, in 7.9, we talked about making alkyl chlorides. And when I first read this, that's what I was thinking of. And it says, right, showing both products. Well, when you have a substitution, you get two products, but it says which one will be made in greater quantities. And that was my clue that this was not a substitution, that this is indeed another elimination. All right, so let's see what I got. All right, so here I have two betas. I do still have a hydrogen on here, right? Because if I look, I only have 3 bonds, so the fourth one must be a hydrogen. And here I have 3 hydrogens, so I can pick any of those. So what if I use this, the first beta? I end up making a triple bond. All right. What if I use the second beta over here? What do I end up with? Oh, do you remember what kind of a diene that is? It's a consecutive diene, by the way. I just thought I'd bring that up again. So which one's going to predominate? Well, if there is an additional bond here, this has one carbon and one carbon. All right. This is where the new carbon or the new double bond is. This has one group, this has no group. So which one is going to predominate? Most likely your alkyne. So that would be 2-butyne. All right. So let's go ahead and see what the next page is. All right, so this page you're going to see is all substitution. Why? Because I'm actually telling you I've got HCl, HBr, HI. I'm giving you one of those 3 strong acids. So this is just a simple swap, all right? So I swapped out the OH and got a water, okay? About 1 octanol and 1. It's a simple swap again. So instead of having 1 octanol, I have 1 bromooctane. And then I get, of course, the water. What about the next one? All right, again, I just swap the H and the OH out, and I get, there you go, I got 1 methyl, 1 iodo, pentane or pentane, cyclopentane, there we go. And then I get water here. And ethylene glycol and nitric acid, remember how, I'm just going to give you the answers. Remember how I did this? I rewrote the nitric acid as this because I want to show you that it's the oxygen that's bonded to the carbon, not the hydrogen, and I get 2 waters. So this side was all substitution. Again, notice there was a commonality on the front and the back, and it is if you can make water, you will make water, and we did that each time. So that's it. So don't wait to be great. We'll see you next time. Bye-bye.